Hello there, I'm back with another video here. I got the classroom coil 2. I just finished the circuit on. I was getting ready to test it out, and I've got my test coil on it, and we're going to see how it works. I'm just going to show a little difference on how you can move the circuit in and out away from the coil and change the output, some things like that. So like I said, this is the classroom coil 2 is what I call it. You can find it on eBay and Etsy and on the website. This ain't the normal secondary that I use. It's just the test secondary and primary. It's just ready to go, always here. Grab it and test the circuit with while I'm waiting on the clear coating on secondary to dry. I usually run these for a few minutes to make sure everything's good before I send it out to a buyer. I do test every one of them and make sure the output is good and through, and make sure we don't have any failures or anything like that. Here we go. Alright, everything was good on that run. The heatsink didn't have any heat at all, which is what I like. I don't like to have to hook up a fan. And I like to make a little more efficient coils if I can, so pulled the circuit back a little bit farther. It should drop the input current to the gate driver, so should be less output. It ran at a little higher frequency than what I was expecting. Just a slight bit of heat on the heatsink. Now I push the circuit back, I'm going to run it again and check it out again. That's good. For this last test I do on each one, I stick the strikeout wire above the circuit, see what happens, make sure everything's still good. Got shocked a little bit through the bulb on that one, which happens occasionally, but not always. It's just a little scare more than anything. I wouldn't try to touch this arc with my bare skin. It'd probably burn pretty bad. I've seen some people do it, but that's just crazy. So here's what we had running. It was just a roughed up version. The first 8 of these or so I sold were all slightly different. They had a little variance. Thought maybe I could see what kind of feedback I got, but and actually didn't hear anything back from anybody, so I guess they all held up well. So I just eventually just settled on this right here. And you can see I use the screw terminals for the MOSFETs. I think this is pretty handy, and well, if you ever want to change MOSFETs out, try different things, it just makes it super easy compared to just soldering them, desoldering them out of the board. It kind of starts messing up your traces and stuff after a while. So this works out pretty good, and I've never had a problem with exceeding the rating of the terminals either. Even on any failures I've had or intentional failures I've created, never did it mess up the screw terminals. I mean, the screw terminals were fine. I've even had some of them where it blew the MOSFET into pieces, but the screw terminals was fine. So I don't think this is going to be an issue, and you know, it's convenience for anybody that wants one as well. I used small primary capacitance or circuit capacitance, 1 UF capacitors. So it's about a half a UF on the drive circuit. I don't provide any kind of capacitor bank or anything like that. I just straight to the primary. They will all be coming with these breakers. There'll be 3 and 4 amp breakers on a couple different ones. I'm doing away with the fuses. It's just as cheap to get the breakers than it is to buy fuses and the fuse connectors and everything. So that's going to be changing, and they'll be sticking out of the side of the box, so you can nice and conveniently set the breaker on it. Sorry, reset. Now the ferrite core for the gate drive, if you read, some people don't recommend the powder coated ones. They just recommend the bare ones, but to me it doesn't make a difference. I've tried several different kinds. For this particular application, I'm just going to say it doesn't matter, especially for the frequency they run at. But you know, who am I to say? This ain't a super powerful coil. It's pretty efficient, but yeah, it makes good fun and great for experiments alike. Thanks for watching, and stay tuned for more videos.